Imagine a world where North America and Europe are no longer separated by the vast Atlantic Ocean. Picture a scenario where the familiar boundaries of continents as we know them today are completely redefined. Instead, picture them as a single, colossal landmass. This isn't just a wild fantasy, it's a vision grounded in scientific theory and geological evidence. It might sound like science fiction, but some scientists believe this is our planet's future. They have studied the movements of Earth's crust and have come to fascinating conclusions about what lies ahead. They call this future supercontinent Amasia. This name symbolizes the merging of the Americas with Asia, creating a new, unified landmass. The idea of continents drifting might seem strange. After all, we tend to think of the ground beneath us as stable and permanent. We experience Earth as solid and unchanging. Mountains, plains, and valleys seem eternal, but the reality is far more dynamic. However, beneath our feet, massive tectonic plates are constantly shifting. These movements are slow, almost imperceptible to us, but they are relentless. These plates, like pieces of a giant jigsaw puzzle, move and collide over millions of years. Their interactions shape the surface of our planet, creating mountains, causing earthquakes, and forming new land masses. The formation of supercontinents is a recurring theme in Earth's history. This process has happened multiple times, each cycle bringing profound changes to the planet. Roughly every 500 million years, the continents come together, forming a single landmass. This cycle is known as the supercontinent cycle, and it has been a driving force in Earth's geological history. Then, over millions of years, they break apart again. This breaking and reforming process is driven by the heat from Earth's interior, which causes the tectonic plates to move. This cycle of merging and splitting has shaped Earth's geology, climate, and the evolution of life itself. The shifting continents have influenced ocean currents, weather patterns, and the distribution of species, making our planet a constantly evolving tapestry of life and land. To understand the possibility of Amasia, we must travel back in time to the age of Pangaea. This colossal landmass was a supercontinent that existed during the late Paleozoic and early Mesozoic eras. It was a time when the Earth's landmasses were not scattered as they are today, but were united as one. Around 300 million years ago, all the continents were joined together in this supercontinent. Imagine a world where you could walk from what is now North America to Africa without ever crossing an ocean. This was the reality of Pangaea. Pangaea was surrounded by a single vast ocean called Pangaea. This immense body of water covered much of the Earth's surface, creating a unique marine environment that influenced the climate and life forms of the time. About 200 million years ago, Pangaea began to break apart. This monumental event marked the beginning of the formation of the continents as we know them today. This wasn't a sudden cataclysmic event, but a slow, drawn-out process. Over millions of years, the tectonic plates that make up the Earth's crust moved and shifted, gradually pulling the land masses apart. Driven by the movement of tectonic plates, Pangaea first split into two smaller supercontinents, Laurasia in the north and Gondwana in the south. This division set the stage for the further fragmentation of the Earth's land masses. The breakup of Pangaea had a profound impact on Earth. It wasn't just the land masses that changed, the oceans and climates were also transformed. New ocean basins formed, altering ocean currents and climate patterns. New oceans formed, climates changed, and life diversified into new niches. The separation of the continents created isolated environments where species could evolve independently, leading to a burst of biodiversity. The continents, as we know them today, are fragments of these ancient supercontinents, still drifting across the planet's surface. This ongoing movement continues to shape the Earth, influencing everything from the formation of mountains to the occurrence of earthquakes. Laurasia, the northern half of Pangaea, was a colossal landmass that consisted of what we now know as North America, Europe, Asia, excluding India, and Greenland. This supercontinent was a significant part of Earth's geological history, shaping the continents as we recognize them today. This massive landmass existed for millions of years, providing a unique environment for early life forms to evolve and thrive. However, like all things in nature, it was not permanent. Over time, the forces of nature began to act upon it, and Laurasia too began to break apart. The breakup of Laurasia was driven by the relentless movement of tectonic plates, a process that continues to shape our planet today. This monumental event led to the formation of the North Atlantic Ocean, a body of water that now separates the continents that were once joined. As North America drifted westward and Eurasia moved eastward, the Atlantic Ocean began to widen. This separation was not a sudden event but a gradual process that took millions of years, and it continues even now. This process of continental drift is ongoing, with the Atlantic Ocean growing wider by a few centimeters each year. This seemingly small change accumulates over geological time, leading to significant shifts in the Earth's landscape. The legacy of Laurasia is evident in the geology of the continents that once formed this supercontinent. The rocks and mountains that we see today are remnants of this ancient landmass, telling a story of Earth's dynamic history. For example, the Appalachian Mountains of eastern North America and the Caledonian Mountains of northwestern Europe were once part of a single, continuous mountain range that stretched across Laurasia. These mountain ranges, though now separated by an ocean, share a common origin, highlighting the interconnectedness of our planet's geological past. Scientists predict that in the distant future, the continents will come together once again to form a new supercontinent. This hypothetical landmass has been dubbed Amasia. The formation of Amasia is still hundreds of millions of years in the future. However, by studying the movement of tectonic plates today, scientists can make educated guesses about how the continents might eventually converge. One leading theory suggests that the Atlantic Ocean will begin to close. North and South America will collide with Eurasia, closing the Atlantic Ocean like a giant pair of pincers. Australia is also predicted to join this continental mashup, eventually colliding with Asia. Section 5 6 continents, or 7, the Great Debate. The proposed merging of North America and Europe into Amasia challenges the traditional seven-continent model. This model, taught in schools worldwide, divides the world into Africa, Antarctica, Asia, Australia, Europe, North America, and South America. However, the seven-continent model is not without its critics. Geologically speaking, Europe and Asia are part of the same landmass, often referred to as Eurasia. The historical and cultural division between Europe and Asia, while significant, doesn't reflect a true geological boundary. The six-continent model, which combines Europe and Asia into Eurasia, has gained traction among some scientists. This model aligns more closely with the geological reality of Earth's tectonic plates. Section 6. Shifting Perspectives. Rethinking Earth's Geography. The debate over Amasia and the number of continents highlights the evolving nature of scientific understanding. As we learn more about our planet, we must be willing to challenge existing models and embrace new perspectives. The seven-continent model has been a useful tool for teaching geography. However, it's essential to remember that these categories are human constructs. They are not immutable truths set in stone. The Earth's continents are in a constant state of flux. Understanding the dynamic nature of Earth's geology is crucial for comprehending the planet's past, present, and future. Section 7. Beyond the Surface. The Implications for Geology. The concept of Amasia has significant implications for our understanding of geology. The collision of continents would trigger massive geological upheavals. Mountain ranges would rise, volcanoes would erupt, and earthquakes would reshape the landscape. These geological events would have a cascading effect on the planet's climate. The formation of new mountain ranges would alter weather patterns, potentially leading to changes in rainfall and temperature. The eruption of volcanoes could release massive amounts of greenhouse gases into the atmosphere, further impacting the climate. Studying the formation and breakup of supercontinents provides valuable insights into Earth's deep history. By understanding these processes, we can better predict future geological events and their potential impact on our planet. Section 8. A World United Cultural and Political Ramifications. The formation of Amasia would have profound cultural and political ramifications. Imagine a world where London and New York City are no longer separated by an ocean, but are instead connected by land. The current geopolitical landscape would be unrecognizable. The merging of continents would necessitate new forms of governance and cooperation. Countries would have to find ways to share resources, manage borders, and address the needs of a vastly different world. The cultural exchange that would result from such a massive continental merger would be unprecedented. Languages, customs, and traditions would blend and evolve as people from different parts of the world interact and share their cultures. Section 9. A New Map for the Future. The idea of Amasia, while still a scientific hypothesis, offers a glimpse into a distant future that is both intriguing and daunting. It challenges us to think beyond our current understanding of Earth, and to imagine a world vastly different from our own. As we continue to explore the cosmos and unravel the mysteries of our planet, we must remain open to new discoveries and be willing to revise our understanding of the universe. The story of Earth's continents is a reminder that change is the only constant. The maps we use today are merely snapshots in time, capturing a single frame in the ongoing saga of our ever-changing planet.